children?
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, children. Yeah, have you all completed writing till here?
Yes, ma'am.
Yes, ma'am.
All of you? Anybody still writing?
Yes, ma'am. I'm still writing.
Okay, you're doing the last one, is it?
Yes, ma'am.
Okay. Let me know when you're done, Madhumita.
Completed, ma'am.
All right. Fine, children, I'll just do it from behind, from this one. So in this figure, PQRS is a quadrilateral. PQRS is a quadrilateral. So see the vertices PQRS, RS is a quadrilateral. P and U are respectively points on PS and RS. P and U are points on PS. See, P is a point on the side PS. U is a point on the side RS. So T and U are respectively the points on PS. The PS and RS are the sides of the quadrilateral PQRS, such that PQ is equal to RQ. PQ, such that PQ is equal to RQ. See here, PQ is equal to RQ. That is, this is given to us. So in this quadrilateral, these two sides are equal. PQ is equal to RQ. And T is any point on PS, U is also any point on SR. We are also given that PQT, see here, PQT, that is this angle, angle 1, is equal to RQU, this one, angle 2. Angle TQS is equal to angle UQS. So with all this, we need to show that QT is equal to QU. This line segment QT, the length of this line segment QT is equal to the length of this line segment QU. Okay, so we'll see the information again. PQRS is a quadrilateral. The sides PQ and QR of the quadrilateral PQRS are equal. Angle 1 is equal to angle 2 given. Angle 3 is equal to angle 4 given. P is any point on the side PS. U is any point on the side RS of the quadrilateral PQRS. So with all this, we need to show that this line segment QT is equal to this line segment QU. Now, normally when we have to prove that two line segments are equal, we take one triangle which has one line segment. So here QT, and we need to take another triangle that has the other line segment, which is QU here. So going by that, we have two sets of triangles. So we can go with two sets of triangles. One is you can prove that a triangle PQT is congruent to triangle PQT. So it will be RQU. RQU. Look at the figure. PQT. You can prove that PQT is equal to RQU. So when you prove that these two triangles are congruent, you will get QT is equal to QU CPCTC. QT is equal, because this triangle has QT, this triangle has QU. A triangle has three sides. So this triangle has a side QT, or the line segment QT as its side. And this triangle has QU as a side. So when you take up these two triangles, that is this triangle and this triangle, show that these two triangles are congruent. CPCT, you will get QT is equal to QU. We could also take up this triangle, this one, and this one. We could also take up these two triangles. That is triangle QTS. You can prove the triangle QTS is congruent to UQS. No, I said QTS, right? So I should say QUS here. I don't know what I said earlier. QUS. QTS, QUS. So you can also take up these two triangles, show that they are congruent. And again, CPCT, you would get this result, QT is equal to QU. Because QT is the side of the sphere. This side is common to this triangle and this triangle. QT is a side of this triangle as well as this triangle. QU, see, we have to prove that QT is equal to QU. So QT is in two triangles. This line segment QT is here and here. And the line segment QU is here and here. So you can take up triangle 1 and triangle 2, show that they are congruent and get this result QT is equal to QU. Or you can take up triangle 3 and triangle 4, show that they are congruent, QT is equal to QU. But when you start with one of these pairs of triangles, when you start with triangle 1 and triangle 2, or when you start with triangle 3 and triangle 4, you will see that we don't have sufficient information to prove that the triangles are congruent. The triangles are congruent or maybe congruent, but we do not have sufficient information to show that they are congruent. When you take a triangle, so you should do all this. You must try all this. List out all the equalities you have in the two triangles. So you will start with the triangle 1 and triangle 2. You will list all the equalities you know in these two triangles. You will see that you don't have sufficient information to show that the triangles are congruent. So then you will think, okay, let me try triangle 3 and triangle 4. So when you try triangle 3 and triangle 4, the same thing. You will see that you do not have sufficient information. You must have 3 relevant equalities. Maybe you will have only 2. So you need another one. You need 3 equalities which satisfies a congruence criterion to show that the triangles are congruent. So you will not have. Which is why you have to take up this full triangle. Listen to me carefully. This full triangle, that is QPS. Class, use the emoji. Raise your hand. Danya. Where were you? Danya, Arjun, Srijana. Why delay? Danya, Arjun. Why delay? Danya, Arjun and Srijana.
Ma'am, I first raised, ma'am, and then I lower the hand, ma'am.
All right, children. So we have to take up. So I was telling you. So since we will not have sufficient information to show that the both the sets of triangles, are congruent, we need to take up this triangle QPS and this triangle QRS. QPS and QRS. QPS and QRS. You can see that QS is a diagonal of the quadrilateral PQRS. QS. See, QT is not a diagonal. QT is not a diagonal. QU is not a diagonal. You can see that QS. The two diagonals of this quadrilateral are QS and PR. These are the two diagonals. So you see that, so QS is one of the diagonals of the quadrilateral PQRS. And we're going to take the two triangles on either sides of this diagonal QS. We're going to take the two triangles on either sides of this diagonal QS. So we're going to take up the triangles QPS and QRS. QPS, QRS, and show that these two triangles are congruent. When you show that they are congruent, you can write two results by CPCT. See, you can either, so depending, you should write depending on which two triangles you are further going to take. What should you write through CPCT? You must write that equality depending on which two triangles you are going to take up to show that QT is equal to QU. If you wish to take up these two triangles to show that QT is equal to QU, then you must say this angle is equal to this angle, because that is a relevant information to these two triangles. If you want to take up this triangle and this triangle and show that they are congruent and prove that QT is equal to QU, then you must say that this angle is equal to this angle through CPCT. Through CPCT. Because you can get both. See, when you're taking up the whole triangles QPS and QRS, you're taking up the whole triangles QPS, QRS. So when they're congruent, angle P, this angle, the full triangle, this angle is equal to this angle, CPCT. Or you can even say this angle is equal to this angle, CPCT. So you will write this is equal to this if you're taking up these two triangles further. You will write this angle is equal to this angle, CPCT, if you're further going to continue with these two triangles. So anything you can write. So that's what you have to do. You'll have to take up these two triangles, QPS, QRS. For that, you have sufficient information. Show that the triangles are congruent, get the result through CPCT, and then take up the, any one of the other two pairs you have. Yeah, prove that they're congruent and you will get QT is equal to Q. So every proof has a story, once you understand the proof very well, you don't have to work every proof. You really don't have to work every proof. You need to understand the proof in depth. You need to have all the information. When you look at this figure, you should know that this information is given. And you can remember the, the proof like a question answer, like I was telling you now. So for that, you need to familiarize, the information. You must have read it several times that the information is, in your mind, and you know how the proof goes. So that's how you can do a quick revision before the exam. So even if you have to revise 30 proofs, you should have revised them so many times that before the exam, you just look at the information. So you know that, okay, first we need to take up these two triangles, do this, do that, and finish it. That's it. 3 minutes of, some oral recalling, you will be done. If you have to every time read the question, understand the information, you cannot revise. Your portions are vast. So repetition is very, very important. You need to visit the proof so many times. For all that, you need to make time. You need to make time for all that. So once you do it, once you go through, see, for some of us, I've seen, it comes very easily for some of them. Proofs just come so easily. Every year I've seen, there'll be at least 2 or 3 in the class for whom numerical sums are difficult, but proofs are so easy. Sometimes they don't even want an explanation. They just know it themselves like that. But there are some others, for whom numerical ones are easy. But proofs are kind of difficult, to remember. So everything can be made easy by, repeating. You need to visit the proofs many times. Once you know that, once you keep repeating that, you will also find it easy. But for some of us, anything is fine. Anything in maths is fine. So wherever you stand, everything, you can achieve any height by practicing regularly. And that is time demanding. It's not easy. It's not easy. It's not easy to just open a book and, revise everything in just 1 hour. You will need you need to practice many times. You should have done some 2-3 revisions. Then before the exam, you can just easily, revise. In fact, the full portions. So please visit the proofs many times and make it easy, children. It's very easy because everything is given. Nothing, no hard work at all. Everything is given to you in the question. You just have to use it in the correct way to arrive at the result. Yeah, now you can go through the proof, children. So see here, we have taken the triangles PQS. Now see here, PQS and RQS. You can name it in any order. PQS, RQS, the two triangles on either sides of the diagonal QS. PQS, RQS. Now, in these two triangles, PQ is equal to QR. PQ of this triangle is equal to QR of this triangle, given. Then we know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Add the two results, so you will get 1 plus 3 is equal to 2 plus 4. So you get PQS is equal to RQS. PQS is equal to RQS. 1 plus 3 is PQS and 2 plus 4 is RQS. And then QS is the common side. QS is the common side. So SA is triangle the congruent. I have taken up 5 is equal to 6 because I'm going to go ahead with these two triangles. I've written 5 is equal to 6 because I'm going ahead with these two triangles. So you please write this one as 5 and this one as 6 if you're going ahead with these two triangles. So 5 is equal to 6 CPCT. Now in these two triangles, now in this triangle and this triangle, see here, angle 3 is equal to angle 4 given, angle 5 is equal to angle 6 we proved, and QS is the common side. QS is the common side. ASA, the triangle congruent, CPCT. If you take up these two triangles, this triangle and this triangle, you would have got this one. 5 is equal to 6 CPCT, this one. 5 is equal to 6 CPCT, this one. So then you will say angle 1, see here, angle 1 is equal to angle 2 here. Angle 1 is equal to angle 2. And then angle 5 is equal to angle 6 CPCT. And then we already know that this QP is equal to QR. QP is equal to QR. That's already given to us. Again, ASA it is. Two angles in the included side. ASA triangle the congruent, CPCT, QT is equal to QB. Wasn't that easy, children?
Yes, ma'am.
Yes, ma'am.
All right, children. Fine.
Yes, ma'am.
Very good, very good. Yeah. All of you, see, I trust you all. I hope you all. Okay, let me ask. So how many of you have finished all the 3 proofs? Raise your hand. Very good. Madhumita, Sanjay, Sindhu, Netra, Tanishka, Danya. Okay, the others, Arjun, Srijana, Krishmika, Shri, and Raja, you're still to write, is it?
Yes, ma'am. The last proof, ma'am.
Okay, Raja.
Ma'am, my internet got disconnected for 10 seconds, last 10 seconds, ma'am.
Okay,
What
what is your
happened?
status? How much have you finished?
Ma'am, I completed. You told last week, right? I completed everything. I mean, last class.
Okay, Srijana and yeah, Srijana. Every class I call out your name for something or the other, but every class there is no response. But I still don't give up. I keep asking you. I don't neglect anybody in the class. I don't get any response from you, Srijana. Still, I keep calling out to you. Again, no response. Fine. Well, it's a Danya, Tanishka, Netra, Sindhu, Sanjay, and Madhumita have finished. Others have little more to do. All right. That's about this proof. This one, children, I didn't send because this is an NCRT. You can, this one we have already done an NCRT, so I did not share this picture. You can take a picture if you want. This is, I think, one of the examples in NCRT. You can take a picture.
Taken, ma'am.
Very good. Yeah, now this one. So in this figure, AY is perpendicular to ZY. AY is perpendicular to ZY. See here, AY is perpendicular to ZY. So the line segments AY and ZY are at right angles to each other. The line segments AY and ZY, they are at right angles to each other. AY and ZY, you know, they are at right angles to each other. So AY is perpendicular to ZY or ZY is perpendicular to AY. Both are the same. ZY perpendicular to AY or AY, see when you say A is equal to B, A is equal to B, meaning B is equal to A. Similarly, AY perpendicular to ZY is also ZY perpendicular to AY. And BY is perpendicular to XY. BY, where is BY? BY. Yeah. BY is perpendicular to XY. Is perpendicular to XY. Okay, again, these two line segments are perpendicular to each other. You can see the right angle marked here. Prove that, okay, XY such that AY is equal to ZY. AY, this one, AY is equal to ZY. These two line segments are equal. It's all marked in the given figure, children. Meaning the figure given with the figure given along with the question, it's marked. You can see the right angle marked here. And this side AY is equal to this side ZY. And you can see that it's marked here that BY is equal to XY. BY is equal to XY. So with all this, you need to prove that AB is equal to ZX. AB is equal to ZX. Where is AB? AB, this one. This one, you know. AB is equal to ZX. ZX. You need to prove that AB is equal to ZX. Now, AB is a side of the triangle AYB. AB is a side of the triangle AYB. And okay, AYB. AB is a side of the triangle AYB. And ZX is a side of the triangle ZX. See that ZX is a side of which triangle, children? ZX.
Triangle ZYX, ma'am.
ZYX. ZYX. ZYX, sorry. Or XYZ, any order we could name it. So XYZ, triangle XYZ. See the triangle XYZ? XYZ. And you can see here ZX. ZX. And the other triangle AYB. You can see this triangle has the side AB. So you need to take up these two triangles and show that they are congruent to each other. So let's just look at the triangles again one by one. Look at this triangle and look at this triangle. The angle, let's mark off the angle ZYX. Let's mark off the angle ZYX. Angle ZYX. Angle ZYX. ZYX. See here. ZYX. This is an angle. This is an angle of the triangle XYZ. You can see the 90 degrees there and one little portion which is not, meaning one little portion here. Okay, this one. In the other triangle that is AYB, see here, this is an angle. Angle AYB. Angle AYB. This is the angle. So you can see the right angle and the same little portion. The same little portion. So I've marked the right angles, angle 1 and angle 2. And that common portion is angle 3. I marked that common portion is angle 3. So see the proof in the two triangles, AY of this triangle is equal to YZ of this triangle. Because it's given, AY is equal to YZ is given. Similarly, YB of the first triangle, it's marked, see here, YB of the first triangle, or this triangle here, this first triangle, is equal to XY of the second triangle. Because it's given again. It's marked, you can see it, all that is given. And then this angle 1 is equal to angle 3, 90 degrees. Angle 1 is equal to angle 3, 90 degrees. Correct? Angle 1 is equal to angle 3, 90 degrees. So we'll add 3 to both the sides. We'll add angle 3 to both the sides. There is a common portion to both the sides. So angle 1 plus 3 is equal to 2 plus 3. So that gives us ZYX is equal to AYB. See, angle 1 plus angle 3 is AYB. AYB or BYA is equal to 2 plus 3 is XYZ or ZYX. So angle 1 is equal to angle 2 is equal to 90 degrees given. Then we'll add that common portion, to both the sides. So I add angle 3 to both the sides. So when you add angle 3 to both the sides, you will get this angle. Angle AYB is equal to angle XYZ. And they are the angles of the two triangles. So again by SAS, because two sides and the included angles here, one side, another side, included angle. What is it, included angle? That is for this angle. These are the two arms. And for this angle of the other triangle, these are the two arms. This one and this one are the two arms. And that's what we have mentioned in the proof here. So by SAS congruence criterion, the two triangles are congruent. So we have AB is equal to ZX CPCT. AB is equal to, so you can see the order, AYB ZYX. AYB ZYX. So AB is equal to ZX CPCT. See, if you don't know or don't remember how to name the triangles in the order, you'll have to go through the first or the second video where we have seen how to write SAS, SSS, SAS, ASA. Yeah. So this what it is, once it's told how to write every other proof, you should know. Okay. Now this one should do. So here, now tell me, have we, I don't, because I don't remember. All this we have to still do, no? Have we done this one, children? Quickly tell me. No, all this we have not done, correct?
Yes, ma'am. We have not
Yes,
done.
Because sometimes I do it randomly, so I'm not sure, like this one,
No, ma'am.
this,
No, ma'am.
this one also, no, I don't remember. Yeah. Okay. I think we're doing the correct order. Till here, I think I remember we finished in the last class, right?
Yes, ma'am. We completed that.
Let me just see all this. This is done. This one is also over, right? I said I'll change the slide. I have not still done it. I'll do it and share that answer on WhatsApp. I told you the proof here is correct, but I'll present it in a more, friendly way. This looks very lot of theory and not very clear, like for students. So I'll just make another. I'll try to make it look more simpler. This I've explained. Yeah, this also we have done, correct?
Yes, ma'am.
Yeah, this also I remember we finished this. Yeah, this also we finished. Yeah, this we finished. Yeah. So I think I'm doing it in the correct order. Yeah, now this one. So in the given figure, ABCD is a square. In the given figure, ABCD is a square. ABCD is a square. As I read, you should look at the question also, meaning the figure ABCD is a square. M is the point. M is the midpoint of AB. M is the midpoint of AB. So Krishmika, tell us, if M is the midpoint of AB, what can you further say? If M is the midpoint of AB, what is your conclusion?
AM is equal to BM, ma'am.
Very good. AM is equal to BM. Now, Krishmika, one more question. If M is the midpoint of AB, can we say that PM is equal to QM?
Yes, ma'am.
Yeah. Okay. How do you say that? It's not given that M is the midpoint of PQ, right? How can you assume M is the midpoint of PQ when it is not given? M is the midpoint of AB is given, right?
Yes, ma'am.
Okay, 1 minute. See, there's a line segment here like this, okay? AB, 10 centimeters. All right. And M is the midpoint. That means this is 5 centimeters here, this 5 centimeters here. All right. Now there's another line segment. See, there's another line segment going through M. There's another line segment. Let me call it PQ. Let me call that line segment PQ. This one is, say, some 12 centimeters. It's 2 centimeters here and 10 centimeters here. But it goes through M. So now is M the midpoint of PQ?
No, ma'am.
No. Just because M also lies on PQ, we cannot assume that M is the midpoint of PQ. So what is
Yes.
given? M is the midpoint of AB. That means AM is equal to BM. M lies on PQ, but it is not given that M is the midpoint of PQ. M only lies on PQ. It's not given that it's a midpoint of PQ. So we cannot conclude that PM is equal to QM. Maybe you later in our proof, we will get this result. Later when we prove, maybe we will get this result that PM is equal to MQ. That's a different thing. Now, as of now, we cannot say that PM is equal to MQ. All right?
Yes, ma'am.
Yeah, good. So M is the midpoint of AB and PQ is perpendicular to CM. PQ is perpendicular to CM. So you can see here PQ is perpendicular to CM. PQ perpendicular to CM meets AD at P. PQ perpendicular to CM meets AD at P. So see here, this PQ meets AD at P and CB produced at Q. All right, so they're talking about the line segment PQ. Okay, one thing is PQ is perpendicular to CM. PQ and CM are perpendicular to each other. That's one thing. This point P, okay, it meets the side AD at P. This point or this line segment meets the side AB at P. And the same line segment does not meet CB. This line segment does not meet CB. This line segment does not meet CB. It meets CB produced. It meets CB produced at Q. It does not meet CB. Like this line segment meets AD. It meets AD at P. In the same way, the same line segment does not meet CB or BC. It doesn't meet. It meets CB produced at Q. That's what is given here. AD at P and CB produced at Q. Not CB. CB produced at Q. Okay, so given this, what are we given? ABCD is a square. ABCD is a square. M is the midpoint of AB. So now next time when you see this figure, you should know the given information. ABCD is a square, M is the midpoint of AB, and immediately your mind should tell you that M is not the midpoint. M is not given to be the midpoint of PQ. Then, the line segments PQ and CM, they are perpendicular to each other. This line segment meets AD at P, but it does not meet CB. It meets CB produced at Q. With all this, we need to prove that PA is equal to QB. PA is equal to QB. So clearly to show that these two triangles, to show that PA is equal to QB, to show that PA is equal to QB, you need to take up these little triangles, this triangle and this triangle. We need to take up these two small triangles, show that they are congruent and CPCT. So as you can see here in the proof here, so this angle is equal to this angle, vertically opposite angles are equal. This angle is 90 degrees. And here this angle is 90 degrees because this is 90, no? This is 90, so this also will be 90. So it's 90 here in this triangle, it's 90 here in this triangle. And then AM of this triangle is equal to BM of this triangle because M is the midpoint of AB. M is the midpoint of AB. So in this little triangle, APM and this little triangle BQM, this angle is equal to this angle, vertically opposite angles are equal. AM of this triangle is equal to BM of this triangle given, and then 90 degrees. 90 because this is 90, this is also 90. So ASA rule, the triangles are congruent. We have to prove that PA is equal to QB. PA is equal to QB, CPCT. PA is equal to QB, CPCT. So that's the first part. PA is equal to QB. So that was easy. You had to take up these two triangles because PA is a side of this triangle and QB is a side of this triangle. So you have to take up these two small triangles. And we have sufficient information, just enough information to show that the two triangles are congruent. Okay, now as of now, we don't know why we should write PM is equal to MQ. How do we know that? So don't write it. So when you're revising the proofs, see, you're asked to prove that PA is equal to QB and we proved that PA is equal to QB. How do we know that we have to write this? Don't write now. Even I don't know that we have to write it now. Nobody can make out that. Don't write now. You go ahead with the next thing. Then you will, when you realize, I want one more information, I don't have, then you should come back. These two triangles are congruent. From this congruency, can I get any information to show that these two triangles are congruent? Then when you think, you will realize that you have to write this. So you come back and you should squeeze that information here. Then, or you can write here itself. If you don't have space to write this, here itself you can write PM is equal to NQ because these two triangles are congruent CPCT. You can write the reason in the bracket like that. If you did not mention it here and you don't have place, you feel it's already congested your proof and you don't have place to squeeze in that information, don't write there. Here in the bracket you must write that this triangle is congruent to this triangle proved. So PM is equal to MQ CPCT. So that reason you write it here itself. So two ways you have. If you have space, you come back here. So you'd have started like this. You'd have written this. You'd have written this. Then you want one more information. So you'll come back here. You'll come back here and you'll include this information CPCT. You'll mark it here and then you'll write this and you'll say from A. But if you don't have the place here, then you can write it here itself. PM is equal to MQ. Write the reason here itself. Now we'll have to prove that CP. The first part was very easy. That is, this one is easy. Now we have to prove that CP is equal to AB plus PA. So let's understand this meaning this this one still further. CP. Okay, CP is equal to AB plus PA. AB. Where is AB? AB. See here. AB plus PA. How can we prove all this? Okay, you're not supposed to measure it with a scale. How can you prove all this? You'll have to prove that CP is equal to AB plus PA. AB plus PA. Looks very complicated. AB plus PA. Now, which triangle should you take up is a question. So many line segments. So now how to, which triangle or which two triangles to take up. So now what you should ask yourself is, okay, let me look at only one side. This is complicated. AB plus PA. Leave this. AB plus PA, just leave it. Look at CP. Where is CP? CP is in this triangle. You can see that CP is in this triangle. CPM. It's in this triangle CPM. So if you take CPM, which is the other triangle you have to take? You have to take CQM. If you take, because now you'll ask me, how do you know that? Because it's given that CM is perpendicular to PQ. CM is perpendicular to PQ. So you have to take triangle CPM and CQM. CQM. You'll have to take up these two triangles. Because ignore this one. Ignore this one. CP is in this triangle. So you have to take up this triangle. CP is in this triangle. So you have to take up this triangle. So CP is equal to what, children, you can prove in the other triangle? CP is equal to
CQ, ma'am.
CQ. You can prove. Yeah. Was that done here?
Yes, ma'am.
Very good. So you can prove that CP is equal to CQ. You can prove that CP is equal to CQ. Okay, so now let's write that. So I can only prove that CP is equal to CQ. Okay, when you take up these two triangles, you can prove that CP is equal to CQ. Somehow we'll write three equalities and prove that CP is equal to CQ. Now, what is CQ made up of? How can you rewrite CQ, children? How can you rewrite CQ? CQ is equal to
PQ, ma'am.
C.
CB plus QQ, ma'am.
CB plus BQ, ma'am.
CB plus BQ. Very good. CB plus BQ. Now, what do we have here? AB plus PA, right? AB plus PA. Now, can you write CB as AB? Because all the sides of a square are equal. Can we write CB as AB? Because in a square, all sides are equal.
Yes, ma'am.
Yeah. So in a square, all sides are equal. So AB, BC, CD, DA, all these sides are equal. So we are replacing CB with AB. We're replacing CB with AB because all sides are equal. Now, we've already proved that BQ is equal to AP. We have already proved that BQ is equal to AP. So we can replace BQ with AP. So that's how we prove that CP is equal to AB plus PA. CP is equal to AB plus PA. So whenever you have to prove a result like this, You can't prove this directly. You cannot directly prove that CP is equal to AB plus PA. You cannot directly get that result. You will get CP is equal to some other line segment. That line segment you'll have to break down and get AB plus PA. You will not get the result CP is equal to AB plus PA directly. You will take up two triangles, they are congruent, CP is equal to some other line segment. That line segment you should break down and replace like this and get this result. So that way it's easy, children. So we need to take up these two triangles. I'm not reading this for you. Look at all this. So they are congruent. CPCT, you get CP is equal to CQ. CP is equal to CQ. And then CQ is nothing but what I just said. CQ is nothing but CB plus BQ. CB plus BQ. But CB is AB because all the sides of a square are equal. And BQ is AP. BQ is AP because BQ is AP here. Because we proved that BQ is equal to AP. BQ is equal to AP, we proved. So like that, we get the second result. I'll just wait for some time. I'll just have some water and come back, go through this proof. And if you further have any questions, you can get them clarified. I'll just get back. Any questions, children?
No doubts, ma'am.
No.
No doubts, ma'am.
No, ma'am.
All right. Yeah, now write down this one, children. This one is actually similar to this one. So I think you can help yourself. Very, very similar to this one. This one, children. Diagrams are just rotated like this and that and given you as a different proof. So yeah, write on this, but as you write, please understand. Please write on this. As you write, please understand. Yeah, start writing. Done, children?
Yes, ma'am.
Doing,
Di-
ma'am.
diagram,
minutes,
Danya?
ma'am.
Have you drawn the diagram, Danya?
Yes, ma'am.
Take a picture and send it to me now. Only this answer, Danya.
Yes, ma'am.
Yeah.
Ma'am, I have sent you, ma'am.
Yeah.
Completed, ma'am.
Yeah. I think my phone is, my storage is full. My phone storage is full. I don't get messages immediately. See, I've not got. You've sent, is it, Danya? I have not received, Danya.
Ma'am, but I have sent, ma'am. Wait, ma'am. I will resend again.
Somebody else who's finished, please send. See what a careless work it is, Danya. Where have you numbered the angles? Huh? And I've told children, take down the question figure as well as the answer figure. How will you know what was marked in the question and what you have marked in the answer? Very careless, Danya, not expected from you. You have not marked the numbers and you have not drawn two figures, one in the question and one in the solution. Yeah, others? Madhumita, Sindhu, Sanjay. Yes. Is it Sindhu or Sanjay?
Ma'am, Sindhu.
Sindhu. Sindhu, darling, where is the question figure? Answer figure you have drawn, but question figure?
Ma'am, I've just drawn one figure and I've marked the angles in that itself, ma'am.
Okay, fine. So you feel that's enough. Okay, Danya, one more thing is you have not marked the angles also. That's what I was telling you.
Yes, ma'am. I will complete and send you.
Yeah. Even Madhumita, only one figure. Okay. 30 seconds to draw it once, 30 seconds for the other one. Why?
Ma'am, I've numbered it with pen to differentiate the question and answer, ma'am.
Oh, you always do that, is it?
Yes, ma'am.
Very good. Okay, fine. Convincing reply. Okay, Danya, good. All right, children, over to the next one. Yeah, believe me, this is also simple. So take a screenshot, you can complete it later.
Taken one.
Please take a screenshot. Please complete it. See, that is left up to your responsibility. You should remember that even the teacher takes effort. For me also, it's not easy to make a class like this. And being online, I have to prepare the presentation for every class. And I collect proofs from different books. I put it in my different order. So even I'm working. So you people also have to take that effort. So if you say, no, she just asked you to take screenshot, doesn't give us time to write in the class, we have so much to, study. So I've explained, I think, quite a lot. So now this is too easy for you to, understand. So you should do something from your side also. Done, children? Taken a screenshot?
Yes, sir. Yes,
Okay. So leave some space. Write question number 13 and leave some space in your book. When it's empty, you will realize that you have to complete it. Yeah. Now write down this proof. We'll do this now in the class. Write down this proof, children. We'll do it now in the class. As you're writing, try to understand something so that when I explain, it becomes very clear. I'm right here. I'm just turning off my video. I'm right here. Done writing, children? You need more time or finished?
Ma'am, the last part, ma'am.
Okay, fine. Finish it, finish.
Completed, ma'am.
Yeah. Others?
Completed, ma'am.
All right, very good. All right, children. So this one we know, because we know that in an isosceles triangle, that is a triangle where two sides are equal, the altitudes drawn on the equal sides are also equal. We have seen this in NCRT. In NCRT, we have proved these results. If ABC is an isosceles triangle with AB is equal to AC, if ABC is an isosceles triangle with AB is equal to AC, then the altitude on AB will be equal to the altitude on AC. We have proved this. CE is equal to BF. In a triangle, when two sides are equal, the altitudes drawn on the equal sides are also equal. The altitudes also will be equal. Conversely, in a triangle, when the altitudes drawn on two sides are equal and the altitudes are equal, in a triangle, not in an isosceles triangle, in a triangle, when two altitudes drawn on two sides of the triangle are equal, when the altitudes are equal, then the two sides are equal. So when altitudes are equal, the corresponding sides are equal. When two sides are equal, the corresponding altitudes are equal. In a scalene triangle, no side is equal. No side is equal. So none of the altitudes will be equal in length. None of the altitudes will be equal in length. In a scalene triangle, all the three sides are unequal. So their altitudes, the corresponding altitudes also will be unequal. The three altitudes, none of them will be equal. In an isosceles triangle, two sides are equal. So the altitudes, so see, in a triangle, there are three altitudes, one on each side of the triangle. So when two sides are equal, two altitudes will be equal. The altitudes that fall on the equal sides will be equal. And in a triangle where all the three sides are equal, equilateral triangle where all the three sides are equal, the three altitudes drawn on the equal sides will also be equal. So when the triangle is equilateral, the altitudes are equal. If the altitudes are equal, then the triangle is equilateral. If all the three altitudes are equal in length, then the triangle is equilateral. Because if three altitudes are equal, then the three sides are also equal. If the three sides are equal, the altitudes are equal. So that's what we'll have to prove here. The altitudes are equal. So you need to prove that the triangle is equilateral. So how do you do this? See, triangle selection is very important. How do you select the triangles? That's very important. So you can see here, I have nothing much to say in the figure. ABC is any triangle. Now it's not equilateral. Now ABC is not equilateral because we have to prove it's equilateral. So we have a triangle ABC in which the altitudes are equal in length. Okay, the altitudes drawn on the three sides are equal. So we have to prove that the triangle is equilateral. Now triangle selection, the proof is easy. How do you select the triangles? So see here, you will not be able to prove that AB is equal to. How do you prove that how do you prove that the triangle is equilateral? So you will prove that AB is equal to BC is equal to AC. But this is quite difficult to prove. So you can prove that the angles are equal. See here. You can prove that angle A is equal. See, in this triangle, you can prove that angle A is equal to angle B. So if angle A is equal to angle B, when two angles are equal, the sides opposite to them are equal. In a triangle, when two angles are equal, the sides opposite to them are equal. So if you prove that this angle is equal to this angle, then opposite to this side is equal to this side. Then you should prove that angle A is equal to angle B. Then angle B is equal to angle C. So that means A, B, C, all the three angles are equal. So that means all the three sides are equal. So the triangle is equilateral. You must prove that angle A is angle A is equal to angle B. And you can also prove that angle A is equal to angle C. Anyways, somehow you should show that all the three angles are equal. Or you can prove that angle C is equal to angle A, angle C is equal to angle B. That's your choice. Keep one angle standard, angle C, angle C. Prove it's equal to A, prove it's equal to B. Accordingly, you should select the triangles. So whatever you want to do. So if you want to prove that angle B is equal to A from one triangle, I mean from one set of triangles, and if you want to prove that angle B is equal to C from another set of triangles, accordingly you should choose the triangles. Accordingly, you should choose the triangles. So to prove that this triangle is equilateral, we are going to prove that angle A is equal to angle B is equal to angle C. We're going to prove that angle A is equal to angle B is equal to angle C. Okay, so we'll have to prove that angle A is equal to angle B is equal to angle C. So if the three angles are equal, then the three sides are equal. So the triangle is equilateral. So to prove that these three angles are equal, fix any one angle. Like say you can fix angle A. Must prove that angle A is equal to angle B and angle A is equal to angle C. So all the three angles are equal. So it's equilateral. So I've given you the main idea. Yes or no, children?
Yes, ma'am.
Yes,
Yes, ma'am.
Okay, so that's the main idea. How do you choose a triangle? This is the main idea. So what have I done? So I have taken a C is equal to B and C is equal to A. I have proved that C is equal to B and C is equal to A. So if I have to prove that C is equal to angle C is equal to angle B, where is my angle C? Here is angle C. Here is angle C. So which triangle I should take up? I should take up triangle BC. Yes or no?
Yes, ma'am. Yes, ma'am.
yes,
So that's why I've taken triangle BC. Then if angle B, where is angle B this time? This angle. See here, this angle. Okay, this one you all said, this triangle. Okay, one more thing I should say is to prove this angle C is also, so okay, angle C is in triangle BCE. It's also in triangle ADC, correct?
Yes, ma'am.
yes, ma'am.
Yeah, it's also in triangle ADC. Where is angle B? Where is angle B? Angle C is in these two triangles. Where is angle B? In triangle ABD. ABD and ABDC. ABD we have this one. And also in angle, and also in triangle
ABE, ma'am.
ABE, we don't have full angle B.
Ma'am,
ABC.
BBF, ma'am.
BCF. In BCF, we have the full angle B. We're looking for the full angle, the complete angle B. So now children, so from this you should make a choice. So if you take this triangle and this triangle, see if you have information to prove they're congruent. If you don't have information, then you should not take this triangle and this triangle. You should take this and this, that's all. So little working you should do. Little working you should do directly. Always you cannot choose the triangles very easily. So again, I've told you that idea, how to choose the triangles. So angle C in angle C is in triangle ADC and in triangle BC. Okay, and angle, which is the other angle, B. Angle B is in triangle ABD and in triangle BCF. So you decide. Now you should decide. So if you want to take this triangle, try this and this. Just do it in the rough column if you have sufficient information to prove that they are congruent and show angle B is equal to angle C. If that's working, you do this one. Otherwise, you do this and this. That's all. Similarly, on the other side here, to show that angle C is equal to angle A, to show that C is equal to A, for C, we understood the two triangles. The same thing you will get here. For C, we understood the two triangles. Now A, where all do we have A, children? Which are the triangles we have A in? Children, A we have in which two triangles?
AB.
Triangle ABE and triangle ACF, ma'am.
ACA,
BE
and ACF, ma'am.
ACF we have, then ABE we have. Now you cannot take up, you don't say, ma'am, in triangle ABC. Triangle ABC, if you take it fully, then which is the other triangle you will take? In triangle ABC also you have angle A. But if you take up the whole triangle ABC, then which is the other triangle you will take? So you can't take the whole triangle. In fact, angle B and angle C are in the whole triangle ABC also. The whole triangle ABC has angle A, angle B, and angle C. Don't say take up the whole triangle ABC. If you take up the whole triangle ABC, then which is the other triangle you can take? So you should not take the whole triangle ABC. Okay, so angle A is in triangle ACF and AB. So now write down. So for angle C, write down the two triangles. For angle A, write down the two triangles and select. How to select? Depending on the information available. Depending on the information available. We have the, what do you say? The altitudes equal, and we have the altitudes equal. The altitudes are equal, and also their altitude. So we have 90 degrees. This is also 90, children. I forgot to mark here. Okay, this is also 90. So altitudes are equal. So that is one information. And altitude, so they're all right angles at right angles. So this is 90 degrees. This is all 90 degrees. 90 degrees. So maybe you'll get some common angle or common side, something like that. Common angle, common side. So you can finish your congruency. Since it time I was not able to read all this, children. I have the next class now. But I think you understood the main idea with the help of which you can easily understand the proof. Yes or no? Please use this idea to understand this proof, children. All right, try it. If it was difficult, we'll definitely do it in the next class. No, anyways, I'll explain this in the next class. But before that, you can do it once yourself. All right?
Yes, ma'am.
All right. Yeah, children, now take screenshots. Please finish all this by the next class. Take a picture. Done, all of you?
Yes, ma'am.
All right, good. This one.
Taken, ma'am.
All right, children. So that's all in this file. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children.